All right, so here's a couple of examples of molarity, molality, and then colligative properties using the change in temperature formula. These next three that I'm going to do here just in this slide, since it's a review, be curious to see how many of my students that'll be taking this test do these three, because these three will be on the test. How about that? So let's take a look at it. Calculate the molality. So you should say to yourself, calculate the molality of a solution prepared by dissolving 175 grams of KNO3 in 1,250 grams of water. I like to write my formula. Molality is, well, let me write it a little bit more in the middle here. Molality is moles of your solute per kilogram of solvent. All right? Well, this one is my solute because it's going into this one. This is my solvent. Got to know which one's which. And I'm going to go ahead and convert that to moles. So grams, moles, X line, you know that whole deal. Where was I on this one? I knew I was one. There we go. There we go. So convert that to moles. It's a 101, which is going to be 1.73 moles. So let's go right ahead. Molality is 1.73 moles over my kilograms. Well, this is in grams, so I'm going to 1.250 kilograms. Do some dividing. 1.38 molal. There's my answer for that one. All right. So let me just erase that, and we'll do another one. I'm going to do all three of these problems right on this one example review page. Is it my previous slide that has the next one? Yep, there you go. Okay, if you want to make up a 0.75 molal solution of Al2SO43, and you need 500 milliliters of it, how many grams of your Al2SO43 go into that? All right, so we're doing the molarity formula, which is moles per liter. Doesn't look like an L very much. Moles per liter. I'm giving you the molarity. I'm giving you the liters. You need to solve for the moles, which then can be changed into grams. So let's rewrite the equation. Molarity times liters, 0.75 molar times 123, 0.500 liters. When I multiply those two, I get 0.375. That's my moles, right? Because that's what I was solving for here. But I want grams, so X line, moles, grams, 1. Add up this whole mess, 342. All right, 342. And remember how we get that? Aluminum is 27 and there are 2 of them. Sulfur is 32 and there are 3 of those. Oxygen is 16 and there are 12 of those. Add all that up, you get 342. Multiply the moles times the 342, you get 128.3 grams of your aluminum sulfate. There's the answer for that one. And I'm going to do one more, and that's going to be a colligative property one. It's going to be a boiling or freezing point depression one. All right. I think it's the next one right here. Okay. When 920 grams of your ethylene glycol, this is C2H6O2, is added to water, the boiling point of the solution is 104.6 degrees Celsius. That's the boiling point. What is the mass of the water used? Remember, this is the solvent. The Kb for water is 0.52 degrees Celsius per mole. Well, we've got two formulas we're going to use. The change in temperature is the Kb times the molality, and then the molality is the moles per kilogram. Let's just see what we have. I have the change in temperature. Now this is the new temperature. That's the boiling point. Water boils at 100, so the change in temperature must only be 4.6. That's important to recognize, right? Because the boiling point is 104.6, but its original is 100, so it boils, its change is 4.6. I have this, which is my solute, and I have the Kb. So I have the Kb. So I have two of these first equation. I don't know this one. How many grams of solvent? I can solve for the kilograms, and then I'll be able to change to grams. I don't know my molality, but I do know this. I'll be able to know this from my 920. All right, so here we go. Let me just move this a little bit over. All right, and I'm going to rewrite that equation as molality is the change in Tb over the Kb, because I have the change in Tb, which again is 4.6. The Kb is 0.52. When I divide, and I went ahead and did that of course already, I get 8.85 molal. Now I'm solving for this. I'm a big fan of getting it out of the denominator. Kilograms times molality equals moles. I'm going to divide both sides by my molality. Kg equals moles per molal. Now the moles, again, of my solute, grams moles 1, 62, is 14.8 moles. So 14.8 moles over my 8.85 molal, which I just calculated. When I divide that, I get 1.672 kg. I want to know how many grams of solvent, so that's 1,672 grams of water. So there's another way of solving for one of these colligative property ones. Hope that's all good. If you looked at these review, then you're in good shape. You should be able to get 3 right on the test.